So, I was never coming back once I left.
Welcome back. Thank you. And we're going to be talking about FAIR data principles next. Has anyone heard of the FAIR guidelines? Yep, several people. So, for everyone else, the FAIR data principle guidelines were created at the International Lawrence Center workshop in 2014 by a group representing academia, industry, grant funding bodies, and publishers. They were published in Nature in 2016. They don't have actual binding power. No one's going to arrest you if you don't follow them, but they are best practices to follow and are generally recognized as such. It's not a standard or specification, but rather guidelines. And ascertaining whether their practices are optimizing the usefulness of their data. So what does FAIR stand for? Findable, accessible, interoperable, and reusable. As I said, people love to come up with these acronyms. And sometimes they're stretching a little bit to make the words fit, but I have no place to talk. My library is called BEST Library at my university. Business, Engineering, Science, and Technology. We also house psychology, but they don't get in. Because how the best club. You can't do it. So, sorry guys.
We could have gone with past.
We could have gone with pest. That would have been really cool. Actually, we could have a little bug as our motto. I'm bringing it up.
You could just let them in phonetically as in best psychology. Yes.
The P assignment. So, FAIR data principles. Findable, and these are the notes that they came up with under each of these. So some of them are a little oblique, or the way that they're described, opaque, I guess is the word I want to use. So we'll unpack some of them. But F1, assign a globally unique and persistent identifier, DOI. Every data set should have everyone knows what DOI is, right? Digital Object Identifier. At least a unique identifier. Some people say it's okay to use handles as well, but for the most part, DOIs are probably the best practice because a lot of publishers require DOIs. So every data set should have a DOI. Data are described with rich metadata that's talked about in one of the other, in the R section. Metadata clearly and explicitly include the identifier the data describes. You know, it's kind of, a lot of this is just common sense. Data are registered or indexed in a searchable resource. So, people need to be able to find the data, obviously. And these are some of the things that help with that. Again, digital object identifier. Most of the time, if someone submits an article to a journal, they'll provide the DOI. If not, there's other ways to get them. Some universities have arranged to be able to provide them. DataCite will generate one for you, so will the Open Science Framework. So if someone has a data set and needs a DOI, for some reason they're not publishing it somewhere where they're assigned one, or something along those lines, there are other ways to get them. Oh, I forgot, I have a mouse now. Okay, so. Under Findable, I was going to mention the Google Dataset search. Has anyone looked at this yet? It's in the beta stages still. People heard of it? Of course, Google's getting into the data business, because what business does Google not get into? So, take a quick look at that. It's kind of nifty. I mean, it's still, as it says, it's still in the beta stages. But if you want to look at anything, any kind of data set, HIV, and they'll link you to data sets from a number of different sources, a number of different sites. And we're going to look at some data sets in the wild shortly. But this is a way to find all sorts of data sets from all sorts of different places. They give you the DOI. They give you the license, which is important, which we'll mention in a moment. And you can go right to the data set wherever it's being housed, as is the case with any other Google. Yeah, it's closely related, I guess, to Google Scholar. You're going to the repository that has the actual data there, where you can download it, look at the metadata, read the descriptions of it, all that sort of thing.
Can you get this through Google Scholar? Like, can you link to the data from a journal article without associated?
From Google Scholar, I don't know that they do that yet. I haven't, I honestly don't know. It seems like something they will do if they have it.
Yeah, for sure.
They're Google, they can afford to do anything. If they want to do it, they'll do it. Fair. A is accessible. Data are retrievable by their identifier using a standard communications protocol. The protocol is open, free, universally implementable, allows for authentication, authorization procedure where necessary. A repository, that's all they're saying. It needs to be in a repository somewhere that people can get to. That has some authentication and authorization. Yeah, you have some standards to control who's submitting information. And the researcher has the ability to control the information. That's what they're getting at. Metadata are accessible even when the data are no longer available. If a data set gets pulled down, is the metadata still available for people to see what was there? That's the idea there. And I've got a list of repositories here. People ever use the R3 data search engine? Yeah, this is, if you haven't seen it, this is another nice little search tool. This allows you to search for data repositories because, of course, there's repositories that are subject-based, and there are any number of them that are specialized and that are recognized within different academic communities, as well as the more general purpose repositories. Like, and there's other ones out there, Dryad, ICPSR, Zenodo, spelled that.
What was the first one
The
called?
first one, Dryad? Okay, let's look at Dryad. Dryad is, I didn't mean to go to their video, especially since we don't have sound. Oh shoot, I thought I had their link to their actual site. Well, I can go right to it here. Dryad.org. And Dryad is, I have to look at my notes here because there's so many of them. Which one was Dryad? Dryad came out of biology, I believe. Yeah. And covers any number of related biomedical data sets. You can submit data to them, or you can just look up data in them, create an account. They have information here for researchers on how to submit data, data best practices. They have an FAQ that kind of explains everything. Human subjects, what I need to consider when submitting my data, that can be very important. We're going to talk about privacy in a minute. But they have, interesting here, Dryad does not allow direct identifiers, of course, but it may contain up to 3 indirect identifiers. So this has all their policies and things, and allows you to sign up and then submit data to them. And you can look through their site and find data. Again, a lot of these links, I have them here so you can look through them and explore them at your own convenience. Another link here is the open source repository software link. This is just a list of open source repositories. Probably a lot of your, how many of your institutions have their own repository? Yeah, pretty much almost everybody. Some institutions have in their policy that if you can deposit your data somewhere else, then do it somewhere else and we'll link to it. So a lot of times these repositories are useful for that. And of course you might want to have the data in more than one place. It might be in your repository, but it also might be in one of these. At RPI we used to use digital, which I wasn't a big fan of. We used DSpace at Miami, which I like quite a bit better. So the I in FAIR is interoperable. Data uses a formal, accessible, shared, and broadly applicable language for knowledge representation. Vocabularies that follow FAIR principles, qualified references to other data. Okay, once again, you have metadata that's following a standard. You link to other data, like if it's a data set that comes from some research that resulted in an article, well, you want to be able to connect this somehow, because people want to know, where did this data come from? A lot of times the data doesn't really even make sense without the research article that explains how it was generated or why it was generated. So, and I've got a link here. W3C has a link, or has a document of best practices for data on the web. That's a good read too when you have the time. Metadata, there's an article on it at the Digital Curation Center, which does a lot of digital curation work in the UK. They're kind of the big, they're kind of the big collection of documents and site to find a lot of information. But they're kind of UK-based and UK, I don't want to say biased, but UK-centric. So a lot of their stuff doesn't apply necessarily, but they have a lot of useful information there. But their information on metadata is there. Consider what information is needed for the data to be read and interpreted in the future, obviously. Understand your funded requirements for data documentation and metadata. Consult available metadata standards in the field. I have a link here that goes through some of the different metadata standards for, in some cases, special uses for certain areas and other more general ones. Metadata, or Dublin Core is, of course, the one that everyone's familiar with, and that one's useful for quite a few cases. But in other cases, there's specialized metadata. The basics the metadata should contain, well, the descriptive metadata, creator, author, title, file name, file location, file size, that's all kind of obvious. Technical, format, compression, software, hardware, OS used, just again, depending on what it is, and depending on how important those facets are, administrative creation, updates, migration, translating to other file types, etc. The R in FAIR is reusable. Data are richly described with a plurality of accurate and relevant attributes. They're released with a clear and accessible data usage license, associated with detailed provenance, metadata domain relevant community standards. So again, these are all things that contribute to reusability. The most important part of this is the licensing. You do need to approach your researchers when you're doing this data curation process. This is one of the important steps, is to decide how the material is going to be licensed. There's 4 different versions of a Creative Commons license that have to do with the amount of control. Does someone want it to be completely open? Do they only want it to be used for non-commercial purposes? There's several different variations here on this. So that's something that needs to be established. So we're going to look at some data sets in the wild. This is exercise number 2. Now I think everybody has, I don't know if everyone has a computer, tablet, something with them. If you don't, I'm going to have you get into groups, and as long as one person in the group has one, that will do. If you go to the Google Drive that I sent out to everyone, this is going to go direct, you'll find, let me go back to my Google Drive, you will find, under handouts, you will find this exercise. It's exercise 2. I'm going to pass out a sheet as well, but if you go to, where'd you go? If you go to, handouts. So you go to exercise number 2. It will have the actual links in it that you can click on, so you don't have to type these in. Sound is going to the microphone. If you can pass those out. And if you want to work, separating groups of 3, 4, 5, or just the people in your row, or however you want to, again, we don't have tables or anything, so it's kind of difficult, but you want to get together in your groups, and there's links to 4 data sets here, and what I'd like you to do is evaluate them according to the principles we just talked about, which again are findable, accessible, interoperable, and reusable. Do they have an identifier? You know, do they have metadata? Does it seem that most of the important metadata fields are there? Does it seem that it's documented properly? Is there a licensing statement somewhere? Is the data described in a way that makes it useful?
Yeah, I love the German code book.
Some of the stuff here I'm going to go through kind of quickly, but once again you'll be able to look at this at your leisure later on. And honestly, some of it's stuff that you might never use if you're not actually a data curator, but you'll be able to at least take a look at it and see what it does and get an idea of what they do. And if you're an administrator especially, what sort of policies you need to have in place. So. Okay, data management plan. Is anybody familiar with the DMP tool? Yep. 2 people. This is a tool that your researchers can actually use to put together a data management plan that will be acceptable to the National Science Foundation, to IOMS, to different grant writing bodies, and you create an account. Your institution, you typically have an account that you can use, and there's some examples here of different plans. And this is overall data management plans. It tells about how the data is collected, the documentation metadata, ethics and legal compliance, storage and backup, selection and preservation, data sharing, which is mostly what we're concerned with, but there's only a few sentences here in this particular document. But data curation is part of a larger area of data services or data management. So these data management statements cover more than we're really concerned with here in this subject, because they concern more also how the data is collected and security matters and that sort of thing. Okay, types of data files. We kind of mentioned this before. It's just important when you look at, what are these files? Do I understand what these files are? Is there a way to find out what these files are? If, I don't know anything about geospatial files, when I look at them, I don't know what I'm looking at. But there's tools that will help you sort of gain an idea of what you're looking at. There's a nice link here to a site at Cornell on their LibGuides that can tell you some stuff about different file formats, so that's pretty useful. Some software that becomes very useful if you're actually doing this are some of these viewers and things. Of course, one trick is always just to right-click, in Windows at least, on a file and view file information that then takes you to their database that explains what a file is. Sometimes it can be a little confusing because sometimes you can have the same extension for different file types. SAV, it can be used for SPSS files, or it can be a saved video game. I mean, it depends. Usually in the context you have an idea. But JHOVE, which is a application that takes a file, opens it, tells you what it is, also tells you if it's well-formed or valid, which is a concept taken from XML, but they're applying it to all kinds of files. So basically what they're telling you is, does the file follow the lowest specifications for that file type? And then it goes one step beyond, and then the second level, one step beyond that, is everything about it properly formatted? Again, it's the same way as in XML. If you write XML, that is valid but not well formed, it'll run, but it's still not quite correct, and there might be some applications or some uses where it won't run right. This JHOVE actually does that with a number of different files and gives you that information. Whether or not that's important for you in curating the file, you generally want everything to be as well formed and as valid as possible. And if you're transforming between different formats, sometimes those kind of things can be an issue. But JHOVE will do that for you. CodeOcean, which I am just starting to find out a little bit about. Who knows about CodeOcean? They're here at the, they've got a display at the vendors thing I'm going to go by. But what they do is kind of nifty. They provide runnable code. I'll give you an example here. Of course, one of the difficult things to, and this is some code here that goes along with an article, and they give you all the stuff here, and you can also run it and get output, put input, output in, and they basically provide a platform so you can archive code in a place where it's runnable. Of course, the downside of that is, what if they go out of business? Again, you're betting. You're always betting. So if I was going to use something like this, I'd also have the code somewhere else, where it can just be viewed. But they make it really simple for people to be able to run that code. Computer code is always kind of a weird issue in this because technically it's not data. I mean, there's semantic issues there. It's not data, but it usually gets lumped under data curation because it kind of looks and feels like data. It's not an article. It's a tool. And depending on what the research being done is, depending on what the article is, code can be taking on different functions. In other words, if the article is about writing code, then the code is a demonstration of the article. However, if the code is being run as part of some experiment that goes along with the article, well, then it's not really the code that's important, it's the process and getting the data. So those kind of things are important because one of the things you need to decide is, do people need to be able to run the code? Is that why the code is being preserved, so people can run it and get their own results? Or is it just a demonstration of something else? So code is always a bit of an issue. Some of the other ones here, there's an SPS. There's an SPS viewer here. That's a neat little tool. Also, if you don't have a site license for SPSS and you don't want to pay for it, and there's viewers like that. If you just go online and search for most file types, I mean, a lot of file types are maybe associated with an expensive piece of software. You don't want to buy the software just to see what's in there or how it works. You can technically, or you can usually find different types. File Viewer Plus, I skipped over that one. That's a universal file viewer, so that opens a great number of files. Another issue you have to keep in mind is privacy when you're dealing with data. And you kind of expect the researcher, especially in something like the social sciences or something where it tends to be more of an issue, you kind of expect them to kind of know this and be aware of it when they submit the data set, but they may not always be. There are direct identifiers and indirect identifiers. Well, yeah, you probably don't want to have social security numbers in data set files or credit card numbers or other direct identifiers, but there's indirect identifiers. Example here is 87% of the American population can be uniquely identified by a combination of zip code, gender, and date of birth. There are little pieces here and there that if somebody puts them together, they can narrow it down to a few people, maybe to one person. So those kind of identifiers can be an issue too, even if you look at them and say, well, date of birth, a lot of people were born on that date, but what zip code are they in? What's their gender, etc. Purdue has a guide here to dealing with sensitive data that is, again, useful to read. And there is anonymization software. Identity Finder is more of just finding if there's sensitive data in a file. It's mostly marketed to individuals, just for you to run on your computer and see Is my credit card number somewhere on my computer where people might be able to find it, or do I have some other sensitive information on there someone can hack in and find? So it scans files looking for things like credit card numbers and social security numbers and any number of other identifiers. But it can also be useful if you've got data sets and you just want to double check and make sure there's nothing, no direct identifiers like that. ARCS is a little more sophisticated. It looks for indirect identifiers, and it will run through a set of files and tell you, if there's indirect identifiers and what the percentage of the risk is that someone could be identified by different combinations of them. It's, like I said, it's pretty sophisticated. Has really long documentation because it does a lot of stuff, and it can also make the information anonymous by going in and scrambling different. There's like 4 or 5 different procedures you can choose to sort of scramble the information in different ways, so it's still useful. But now someone isn't going to be able to go in and identify somebody in some study just by looking at some of the individual data put together. Some links for some software that has to do with tabular data management. Again, these are just a couple little tools, the kind of things that you might be using if you were actually doing this. Right Field is a little application that when you're dealing with tabular data, when you're dealing with a spreadsheet of some sort, what it will do is you right-click on a field and you're given a choice of vocabularies in a bunch of different disciplines, and very, very granular as far as how much detail it goes into. And you can choose one of those vocabularies, and it will make suggestions of what that label could be changed to that would be more standardized. Now again, we're going back to that issue of communication. There's some negotiation between you and the researcher about things you might think need to be changed. At the very least, you want to have permission for anything you do. They might be happier if you did it, though. So in some cases, it's kind of like, hey, I'd like to make this change, and this change. Is that okay? And if they say okay, the tools like this make it really easy to just simply do that, which again standardizes the information more. Sledgehammer goes through, again, different files that are cell-based, like some of the statistical stuff and some of the social sciences stuff, again, SPSS and Strata and some of the other applications like that. And it allows you to look at that data, convert it to CSV, apply different kinds of metadata to it. It deals with all that kind of stuff. So again, that's a nice little tool to use. But if you're not an actual curator, you probably wouldn't use these, but they're good to know about. Documentation, which is very important. Of course, any of these typical project management software packages usually have ways to save correspondence and things like that. Or you can just save all the emails in a text file and attach it. That works too. So digital curation profiles. I want to make sure that we got a chance to talk about this. Is anyone familiar with these? These have been around for a while. DCPs, yeah. They're very useful. What these are short, 1 or 2 page, a couple pages, descriptions of the data that's being produced by a particular project. A lot of times they can be generalized, though, to other projects. And why is this useful? Well, it's useful to the person working with the researcher on this individual project, because what they're doing is interviewing the researcher and getting the information they're going to need to be able to properly interpret the data that they're going to be curating. But a lot of times, you can look at someone else's profile if it's an area close to the data that you're working with, and it can often help you understand what that data is about. I can just give you some examples here, and this link takes you to a page that has a whole toolkit on how to create these. If we look at an example here, this is one in astrophysics, done by one of my colleagues at RPI, and there's a very formalized structure to these. Stuff about the curator, about who they're interviewing, all this sort of thing. But the important stuff is down here. There's a survey of what the needs are, kind of an overview of the overall research with quotes from the interview. who the intended audience is. That's very important, because if you're looking at the data, is the data something that would be clear to that particular audience? Funding sources, because that's important, because you want to make sure that the way the data is being stored and made accessible is in line with the policies of that particular funding source. And information about how the data is collected and put together and the formats it's in, all that sort of stuff that can be very useful to you, again, especially if it's a field that you don't know a whole lot about necessarily, and you don't necessarily know about the data in the field. Here you get a list of the types of data that are going to be in there, where they came from, how, what they are, what format they're in. So that's a data curation profile. Let's see, where are we at on time? Because the next exercise was going to be to do an actual interview. Let me decide. What time we got?
10 past 11.
10 past. I think we're going to move on. Let's tell you what the exercise was going to be. But if you look at the toolkit, if you look at the links there, you'll understand how the thing works anyway. What I was going to have you do is interview each other as curator and researcher, but that's what's done. That's how these profiles are put together. There's a form that's linked to in here. The toolkit has a form for interviewing that's very standardized. Ask this, ask that. It's very by the number. You don't necessarily have to follow it that closely, but the idea is that you interview a researcher to understand what they're doing, where their data is coming from, what they do with the data, what kind of data it is, and get all that down on paper to help you curate, but also to help other people who are working with a similar researcher in a similar area. And there's a whole list of those I'm linked to there. Yes?
I'm observing as we're going through this that, analyzing the files and making sure that they're anonymized correctly,
Yes.
and making sure that things work well, then doing a data curation profile interview. Seems to me that the communication part is extremely labor intensive. So if you've got, 1,000 researchers who are, generating data throughout the course of the year, what kind of a staff do you need to facilitate the level of work that we're talking about here?
Well, it has to be scalable. So one of the reasons I'm pointing out that there's a list of data curation profiles other people have done you can look at. You don't necessarily have to, because most people aren't going to have the time to interview every researcher they're working with. Someone else has done that for something similar that you can use as a bit of a guide.
And where would I find that?
Oh, it's linked here. I've actually got a link here. I went through that kind of quick, but I have a link to the guides they have online here. Oops, I went too far back. Digital curation profiles. Yeah, here at Purdue, they have a number of them there. But
And I'm not saying it shouldn't be labor intensive. I'm just saying, oh my God, like.
Yeah, it's somewhat labor. It's labor intensive, but it's as labor intensive as. Okay, we're going to go on here because we're going to address that directly, actually, in this next section.
Well, I was going to make a comment about the profile. I'm kind of excited about this. Is one thing that I've been thinking about is having some kind of template where we would know the questions to ask vendors and publishers who we're buying data from, so that we in acquisitions can prep it for cataloging. And there's a big gap there because we don't even know what to ask, or the metadata department doesn't know what they need. And so having like a checkbox and being able to interview vendors essentially about the data seems so helpful. It doesn't have to just be the researcher.
Yeah, absolutely. Those FAIR principles, apply to purchase data as well. That's a very good point. I hadn't really been thinking about this. Yeah, we all purchase data, and a lot of times don't necessarily understand what we're purchasing, other than that someone's requested that we purchase it.
Exactly.
So, Yeah, so we don't know what we're getting. But I think we're going to address some of what you're talking about here in this next step. I mentioned the Digital Curation Network before. That was a group that came together. Well, the Digital Curation Network has come together in the past couple of years, and what they're trying to do is put together a network of people at different institutions that can kind of help support each other. They're putting together a model whereby if you have data sets in a certain area and someone over here is an expert in it, you can sort of share resources and share things back and forth, which is a really good idea, I think, if they're able to finally pull this off. But they came up with, I went to a workshop with them a couple of weeks ago. They put this particular model together as the overall workflow, which is what we've been talking about, that you would go through here. And again, it's scalable, so it's not like a place with a whole staff in data management is going to be different than a place with one person, or a place with one librarian that's doing everything, in which case it's probably not going to happen at all. But depending on the resources available, there's different levels that you can take this to. But these overall steps are the general steps that you're always going to take. What level you go to is what might have to change in different circumstances. So curate, the curate model, check. Let me go through all of them first before I look in detail. C is check files and read documentation. U, understand the data. R, request missing information. A, augment documentation and metadata. T, transform file formats for reuse. E, evaluate for fairness, for the FAIR guidelines. So the first thing you're going to want to do is when you receive a deposit of a data set is check the files, maybe using some of those tools I talked about, but just make sure that nothing's missing, everything's there that you were supposed to get an idea of what kind of files are they, is there documentation, does the documentation make sense? The next step is to understand the data, make sure you understand, what are these file formats, what do they go along with, what is this data, what produced this data, is it just raw data produced by sensors, is it something that's been interpreted or been generated by some sort of software, just understanding what's going on so you can see what's missing. That's the point we keep coming back to, what at this stage is what might be missing here. So the next step is then to request that information from your researcher and then come back, augment documentation and metadata based on that, what still needs to be done with that data, transform it into a file format that again is going to have some longevity, and then evaluate and make sure that it meets all those fairness guidelines. So again, check if it's code, you might want to run it, you need to review the content, the documentation, understand it. Again, this is all stuff that has to do with understanding what it is you're looking at and understanding the documentation and deciding whether or not the documentation is sufficient that someone else in that field, whoever the audience is, would be able to understand it. Making sure often that there's a good README in there or something equivalent to that, which is where a lot of your metadata is going to come from. Request, and again, this gets to the labor-intensive part. If there's gaps, sometimes you decide on the priority of information. Some stuff might be real important, some stuff is not quite so important. Contact the researcher, preferably via email, so you have a record of it, to ask about missing information. Keep it simple and to the point. Some people say, no more than like 4 things. Identify what are the 4 most important things and ask about that. And try and ask in such a way that it will just be a yes or no. That you don't have to get into lengthy conversations. It's just, feel that these labels are ambiguous, need to be changed to this. Is it okay if we do that? Yes, no. Because again, the researcher doesn't want to get caught up in a big, how many of you have sent emails over and over again to a faculty member and you never hear back, and you never hear back? And, so you want to help them help you. Here's an example. This is from the University of Michigan's, their data curation department, and they have like a template. A lot of the institutions in the data curation network, they have their own individual templates like this. But you know, it's just thank you and figure out what the most important questions are and sort of explain why you need to know this. But again, keeping it short and sweet. They don't want to read anything lengthy. If they kind of get the idea of, oh, I just need to say yes or no, or this is just something I need to sign off on, okay, great, here, let me go on to something else. When you get to things like licensing and stuff like that, they might have a few more questions about it if they haven't already thought about that. And augment, again, whatever you've learned in that request stage, that's where you apply it. Create metadata if it hasn't already been created, or work on it to get it where it needs to be. Any sort of standardization, things like dates and stuff like that. And compile your curation log. What's been done to the data? What correspondence have you had with the researcher, etc. So you have that on file as well. Yeah, that's just an image of a metadata editor. And the basic metadata that you need to make sure is there. Again, this is kind of common knowledge, I think, but author, title, keywords, abstract, language, citation, any links necessary, licensing information, funding information, all of that stuff. And make sure you transform it to an archival format. And I have a link here to some recommended formats from the Library of Congress that you can look at. But again, some of the standards here are lossless rather than lossy if it's any kind of a media file, because lossless media files can easily be transformed to other things without losing anything. Even if it's not as high quality of a file, you won't lose any more quality if it's in a lossless format. Something that's widely adopted and independent, again, you're looking for longevity, something that is going to be used. I know when we were at RPI Digital, we used JPEG 2000 a lot, and I kind of question the wisdom of that now because I don't think it's really taken off like it was supposed to. It was supposed to be the archival format, but I think there's some issues with rights and things like that that have made it kind of difficult for it to have become that. So you're just making your best guess of what's going to be around for a while. And some things are, CSV files, TXT files, PDFs are probably, PDF is proprietary, but it's become such a standard, it's probably always going to be around. And evaluate fairness, which we went through and did that with some data sets. So, let's see, I was going to walk through an example, or maybe have you work on some on your own. Let me ask you, how do you guys feel about, I have some data sets in there that are not curated. How would you feel about in groups trying to work through those curate steps with that? Do you feel like that's something that you could do at this point, or would you want to just watch me walk through something? Just want to watch, okay. I wasn't sure how hands-on, how dirty you wanted to get. So.
Well, probably it would be good if you walked through one before we ever tried, at least for me.
Yeah, okay.
And it would also ensure that we get through all the steps and the time that we have.
Yeah, which of course, in reality, this would take a little while, but we're just going to kind of go through it like a, so I have a link to one here, and this is an example of some computer code. And let me find my notes here. Okay. So if we're curating this, there we go. First thing we want to do is check to see what do we have here. I happen to know that this is these are Python files, docx, so I've got a document, and I've got some basic data here for running the file, and I've got a README. So maybe the first thing I want to look at is the README. Okay, so what is this? Core model used in this paper is implemented in a file named, gives the file name. Okay, this is a Python module. Okay, good. Describes the logic of the model. This second file is a Python script used to manage the running of the model. One can study the model using this file alone. Place the file, so directions on how to run it. You put it in the same directory. Of course, you've got to have Python installed, and then you can run the script. Now, I've actually done this. I worked on this in a group, actually in a workshop, and I've done this and go through all the time of doing that. But we ran the script, or ran the code, and it ran fine. Took a long time, but it finally came out. So okay, it runs. Weren't necessarily sure what it was doing. There's not much explanation about that here. So it ran for a long time. We got some numbers, but in order to really understand what it is it's doing, we had to look through some other things here. Here's a basic metadata document. So okay, this is telling me a lot more. This is telling me the title and the author, software associated with, okay, so this is a journal article, I'm assuming, and this is the software that goes with it. Okay, and here's an abstract. It includes Python scripts used to manage the running of the file. One can study the model using this file alone. Okay, place this file in the same directory. Once again, the instructions on how to run it. No keywords. Oh, good. We are told the programming language and the version, which is important. Software requirements, nope. Funding, nope. Licenses, nope. They do have a statement of data use, which is not really a license. It's expressing what would be in a license, so you could suggest a Creative Commons license that would meet these criteria to this person. There's no embargo statement. There is a link. Oh, this must be the journal article. So it would probably be very useful for me to look at the article and read the article, or maybe just the abstract. The abstract might be enough. And basically what this article is it's based on game theory, and you're putting a couple variables in and seeing how different agents interact depending on what the variables are. You don't have to understand a lot of detail to just get the idea of, okay, so this software is run to prove the argument made in the article. So that tells me the software probably should be able to run, because the point of it being out there is so other people can take it and try and do the same sort of experiment, or put their own data into it and see what comes out, and see if it backs up the arguments made in the original article. So let's go back and look at what else we've got in this package. Let's look, if we can, let's look at the code here a little bit. And if we, I don't know what, current file, I'm not able to open that here. Okay, that's fine. I can open it locally. Downloads, and where's my code at? Okay, here's the same files. I've got them locally here, so they're always easier to look at. So I'm going to open this in, let's see. I'm going to open this in, we'll open it in Sublime. And so this is just a simple editor. Now, people use Sublime. You're familiar with Sublime. It's a simple coding platform. But there's any number of things. You could do this in Notepad. Any number of things can open a script like this. So I'm noticing, wow, when I go, this is actually the program, but they've got a lot of explanation stuff in here, description of models, model of coadaptation behavior. Okay, this is explaining a lot of stuff. It wasn't in the README text though. It wasn't in that metadata document. Here it's actually in the code. So this is telling us that this is, some of the things I'm already seeing I need to ask about are, I need to ask about, and kind of prioritizing here, licensing. You know, here's the Creative Commons licenses. Which one of these do you want to apply to this? Based on, and again, if we want to do a yes or no, based on what you said in that statement, I think you want to apply this. Is that okay? Yes or no? With this, it may be there's a lot of information in your comments, in your script, that seem like they would be very useful in your README file. Is it okay if I modify that? And you should get a yes or no answer for that too. Again, the best way to try and word these things is in a way where someone doesn't have to put a lot into it to respond to you. So I'm probably going to want to take this information and put this in my metadata and in my documentation. So let's go back again, see what else is here. And again, this is the file that you use to read it. This parameters test run, that's the data that came out of it when I read it, when I ran it before. We looked at the metadata. So we've looked at several things. We kind of have an idea of the sort of things we want to ask. After we ask those things, if we get yeses back for everything, then we go in and make those changes. You know, we would put in the metadata, you know, which is in a Word document here, which of course we're not going to keep it in a Word document, because that's not that is a proprietary format. Plus, you're going to edit it in some metadata editor, whatever schema you decide to apply to this. You're going to use this basic information, but we can put the information in this document first to sort of use as a model to pull information from and then put into our metadata. So we're going to change this document. We're going to apply a license to it, and so after we do those things to augment, and there's more little things we'd probably do if we spent a lot of time looking at it. There's probably a lot of little suggestions we could come up with, but again, it's time. It's sort of time and resource sensitive. We don't want to spend too much time or use so much of anyone else's time. We only have so many people and so many hours to work on this, so we want to prioritize. So then we're going to make those changes. Transforming file formats, we probably don't need to do that. We have Python is pretty standard. We're told the exact version of the Python language it was written in, so as long as we include that. And we may want to take advantage of something like Curation to actually have a runnable capsule of it online somewhere you can point people to while still maintaining the original document so that people can see that or run that if the one we have stored on Curation should ever cease to exist for any reason. And then for fairness, again, we would go through and sort of look at this stuff after we've done all of our changes to it. After we're done with it, we would go through and go back through and look through our metadata we've created and make sure that we've met all the fairness guidelines. Make sure a DOI has been applied to this. I didn't really see that anywhere in the documentation, so again, that's something we need to go back to the researcher about. We need a DOI for this. And we've got the metadata, we've got the DOI, we've made the changes. So at that point, after we've done all that, we're ready to ingest the file into our repository. So that's just a quick run through of this. This would really take much longer than this. You'd go through a lot more detail. I'm just kind of running through it quickly. So I'll give you the opportunity now, if you want to go back to the drive that you have, let's see, Charleston, and go to datasets. There's several folders. Originally I was going to have you work in groups around tables and stuff, but you know, this isn't really set up for that. So what I'd ask you to do instead was, if everyone here has something to access the internet with, where you can kind of look at the files, pick one of these folders and take a look and see what's in there and see if you can apply that curate workflow to these folders. Again, just in a very cursory way, just to get a feel for what happens in these in this procedure. Take a quick look, check the file, see what's in there, see if everything that needs to be there is there, see if you understand what it is you're looking at, and if not, can you find out what it is you're looking at? Come up with the questions, come up with 3 or 4 questions that you would like to ask the researcher before you would move on to actually deposit this anywhere. So the colonialism one is a history project. Tabular data had to do with water quality. There's a psychological study in there, and there's some very techy stuff here about some sensors, although they're all just text files. But
Could I ask you something?
yes.
So the colonial, the code book, there is a little English snippet. Most of this is in German, so should there be some standardization about what language?
Well, the metadata should mention what language or languages are being used in the document. I mean, it wouldn't have to be translated, but just needs to be noted somewhere that this is in German.
Why has GER in the final name?
Yeah, but that's a hint. That's not exactly, that's not exactly clarity.
I know it does say German English up there.
Okay, so that was in the metadata, okay.
But it's not interlinear, like an art book where one column is Italian and the other column is English, and it's exactly the same content.
Yeah.
This is more little subjective snippets with some English interjected.
No, it's qualitative data, so yeah, it's just pieces from interviews and stuff like that. So the data, translating it is not a necessity. That's up to the person using the data to be able to read German or to be able to get it translated. That's not our responsibility at this end.
Okay.
As long as you're putting the data out there and saying this is German, you need to, right, in the same way, running the code, like the Python code, you need to know how to run Python code to be able to use this.